Thursday, I think we worked this problem, and I'm going to make it a zinc hydroxide problem to go along with your quiz. On your quiz, we learned that zinc hydroxide has a KSP of, is it 3 times 10 to the negative 16? Did y'all see that on your papers? And you guys can just take notes right on there. Yeah, 3.0 times 10 to the negative 16. Okay, so remember, there was a type of question that I think you had Thursday night for WebAssign and maybe also Friday night, and it said this. Will a precipitate form when 0.01 molar zinc nitrate is mixed with 0.004 molar sodium hydroxide? Okay? So this is a little different. We're not being asked for molar solubility. And are we being given equilibrium concentrations? Is there any indication that those concentrations are at equilibrium? No. In fact, that's kind of what we're being asked. By being asked if a precipitate will form, we're being asked whether it's at equilibrium. Because remember, guys, there's a maximum amount of zinc ion and hydroxide ion that can fit in solution. And that would make it a saturated solution. If you have the maximum amount of each, then that is at equilibrium. If you have too much, more ions than you're allowed, what's going to happen?
Precipitate.
All the extra ions will precipitate out. What if you don't have enough? Then it's unsaturated, and so it's not going to precipitate. In fact, you could dissolve more in there. So what we're going to do here, kind of like we start all these problems, is we're going to write out our reaction. And we always write them out in the direction of the solid and forming the ions. Because the tool that we have to work with is KSP. And the KSP goes along with this forward direction. Okay? We're also going to write down our KSP expression. Even though it doesn't say write the K expression, that's where you have to start. So we're going to have zinc to the what power? What power will the zinc be to?
Yes.
1. And hydroxide to the what power?
To the second power.
To the second. Now, let me ask you this. When I'm going to plug in some numbers here, will I be calculating a K?
No.
Technically not. What am I going to be calculating?
The Q.
A Q. That's the strategy. Kind of like on that one quiz question. We're going to put in the concentrations that we have, get a Q value, and compare that to K. All right, so where can I find my zinc concentration? Where in the problem? You guys see this? 0.01. Zinc nitrate is totally soluble, right? So won't it make 0.01 moles or molar of zinc?
Yeah.
Okay. All right, star. See if you can find out the concentration of hydroxide from the problem. So we've got the 0.01 zinc nitrate.
So the 0.04.
Is this going to be totally soluble, the sodium hydroxide? Yeah. So the hydroxide will be this? Absolutely. So we're going to plug this in. And what does our K expression or our Q expression say to do to the 0.004? Square it. Okay? Pop that in your calculator. Tell me what you guys get. Times 10 to the negative 7. I didn't hear the first part?
1.6.
Thanks. 1.6 times 10 to the negative 7. Now remember, guys, this is the Q value. How does it compare to the K?
It's bigger.
It's huge compared to the K, isn't it? The K is 10 to the negative 16.
And then that goes back towards the reactant.
That's right. The Q is way too big. So if the Q is way too big, it goes backward. And what is backwards?
Towards the reactant.
Toward the solid, and the solid would be a precipitate. So the other way to think of this in terms of our KSP expressions is when Q is greater than K, a precipitate forms. Does everybody see that?
Yeah.
If Q had been smaller than K, then no precipitate forms. Okay? What happens if Q is exactly equal to K?
Nothing. It's
No.
not equilibrium.
Again, no precipitate would form. You have to get a little bit above it in order to have things settle out. So it would be at equilibrium, but no precipitate would form. Okay?